Hello everybody and welcome. Today we are going to start a new chapter which talks about something called momentum and impulse, and we will be starting with momentum. So first of all, to be able to deal with momentum, let's try introducing some examples that will help us what really momentum means. Okay, so let's start with this example. Imagine you have two toy cars. One is big and heavy and the other one is small and light. So we have here a big and heavy car and here we have a small and light car. So let me ask you a question. If you push both cars with the same amount of force, for example, you're pushing them with the amount of force equal to 1 Newton, which one do you think will move faster? Okay, well actually it's pretty clear. The smaller and lighter car will move faster than the heavy and the big car. Well, that's because it's easier to make something light move quickly than something heavy, and I think that is really common sense. Actually, we introduced something like this before, and it was called inertia. So momentum and inertia are approximately the same thing. We can say that momentum and inertia are approximately the same thing with very minor differences. So as a quick revision, light things are easier to push than heavy things. Now we can start talking about momentum. Now, if I want to introduce what momentum really means, actually it's a property of moving objects that tell us how hard it is to stop or change their speed. So it's like an indication of how hard is it to move an object. If it's difficult to move an object, we can say that it has high momentum. If it's easy to move an object, or in the other way, stop an object, we can say that it will have a low momentum. So it's only an indication, or it's a property of moving objects that will tell us how hard it is to stop or change an object's speed. Now, it's very important to keep in mind that momentum, it's a vector quantity, and as a quick reminder, this means that it needs a magnitude and direction to describe it. Now, momentum depends on two things. Actually, it's very simple. The first thing, I think it's already clear, which is the mass of the object. So we can say if an object has a high mass, it will have a high momentum. The other factor is the object's velocity. Okay, so high mass and high velocity will give me an object that has high momentum. How did we know that? Well, let's look at the relationship that connects mass and velocity with each other. We can say that the equation of momentum is simply mass multiplied by velocity. It's very easy, very straightforward, and very simple. So it's simply mass multiplied by velocity. Now we already know that mass, it's a scalar quantity, while the velocity, it's a vector quantity. Therefore we will have that momentum will be a vector quantity. Okay, so the unit of momentum, it's very straightforward because we know that the unit of mass, it's kilograms, and the unit of velocity is meters per second. So it's kilograms multiplied by meter per second. So nothing fancy about it. M is the mass and V is the velocity in meters per second. So we gotta keep in mind that if mass is not in kilograms, it's better to change it into kilograms, especially that if some of the masses are in kilograms and some of the masses are in grams, we have to have unit consistency. We can't deal with some objects having the mass in kilograms and others in grams. So this is very important to keep in mind when we solve momentum questions. Okay, now, so if we go back to our toy cars example, the big heavy car will have more momentum than the small light car if they are moving at the same speed. So if they are moving at the same speed, it's clear that the momentum of the heavy car will be
higher than the momentum of the light car.
So now we understand what momentum means. Stay tuned. In the next videos, we will be introducing something called the conservation of momentum, and we will be introducing another term called impulse. So stay tuned.